In April 2010, the Eyjafjallajökull volcano in Iceland erupted, sending a plume of ash into the jet stream, where it quickly reached major cities in Western and Northern Europe. Thousands of people were stranded at airports around the world as 20 European countries closed their airspace for 6 days. The economic impact was estimated at $5 billion. Volcanoes emit clouds of ash and sulfur dioxide gas. The ash consists of sharp-edged silicate particles which can abrade and erode aircraft parts and melt into volcanic glass in jet engines. The ash clouds are difficult to spot away from the volcano because they don't show up on airborne weather radar and can look like weather clouds from the cockpit. Although volcanic clouds are difficult to distinguish, the sulfur dioxide is detected by sensors on NASA's Aura, Aqua, and Sumi NPP satellites. Scientists at NASA's Goddard Space Flight Center developed a way to use sulfur dioxide as a proxy to identify and track ash clouds.
The volcanic clouds, they're moving very fast from big eruptions, so the satellite data are ideal platform to monitor these clouds globally when they move with the winds in the jet stream.
Dr. Krotkov is leading a new NASA-supported project to integrate critical satellite data about volcanic clouds and sulfur dioxide into the models and tools used by the agencies that track volcanic clouds and issue alerts.
The main hazard from eruptions in Alaska are explosive volcanic eruptions that put ash clouds up into the air. There's about 25,000 passengers per day that transit over volcanoes in Alaska, and Anchorage is a top 5 air cargo hub in the world. We work cooperatively with the Federal Aviation Administration and the National Weather Service here to get the warning messages out to the aviation community and as well to the general public. Aircraft move at in excess of 500 miles an hour, and so the faster you can get data in, process it, and have it available for analysis, the better you are. The new capability receiving OMPs here directly in Alaska is a great improvement. We're able to get the data just within tens of minutes after overpass. And there are many cases where by tracking the SO2, you're able to get a better picture of the full extent of the volcanic cloud. We're going to try to integrate those data products into our near real-time data viewing system, and then make that available to the National Weather Service in near real time.
When we issue volcanic ash advisories, we're not always very clear on precisely where the ash is located. Instead of drawing a large polygon that describes where the hazard may be, this would allow us to fine-tune that and perhaps draw smaller areas.
So the goal of all the agencies that respond to volcanic eruptions is to make sure that lives and property are protected. But just as importantly is to try to minimize the disruptions to the air traffic system.
Other agencies using the NASA Volcanic Cloud Alerts include the NOAA Volcanic Ash Advisory Center in Washington, the European Support to Aviation Control Service at the Belgian Institute for Space Astronomy, and the Finnish Meteorological Institute. A private company called Metron Aviation is using the NASA data and alerts to develop a web-based tool which calculates the impact of a volcanic ash hazard in terms of additional flight time, exposure to the ash, and blocked routes. The tool is designed to help the aviation industry determine the safest and most efficient way to use the airspace. One day, the kind of long and widespread disruption that occurred in 2010 may be history. Near real-time data and alerts from NASA satellites will help keep planes and passengers safe and on their way.